Hello everyone, it's Dr. Zach. We're going to review approximation today as you prepare for your AP exam. Let's get started again. For today's lesson preview, you were reminded that it is essential to know how to write the equation of a tangent line. You're also reminded that in order to determine whether or not you have an over approximation or an under approximation, find that second derivative and determine whether your function was concave up or concave down near the value that you're interested in. For part B, you are reminded about differentials. So what happens when one of your variable changes? How does that affect measurements for your different calculations? So, just in case you have forgotten or need a refresher on linear approximation, you will find the information about differentials and linear approximation in your note packet today. For the next part of today's lesson, I want you to set aside 15 minutes to complete the free response question. This grass clipping question was given on the AP exam a few years ago. So take 15 minutes, use the graphing calculator, complete the problem to your best of your ability, and then I want you to grade your answer using the AP rubric. The answer has been attached to your notes, but do not grade it until after you complete it entirely on your own. Turn the video off, spend 15 minutes on this question. For the next part of your notes, I wanted to remind you about estimating area under a curve. When you estimate, you could use rectangles. These rectangles, you could be using right endpoints, left endpoints, midpoints, or upper and lower values. For example, if you're asked to draw 5 rectangles to represent f of x equals x to the second power on 1, 3. These are the different endpoints that you would use depending on what the question requires. You can also estimate area under a curve using trapezoids. Now, the thing that you want to make certain is that your delta x's for both your rectangles and your trapezoids do not have to have equal widths. So be aware, if you do not have equal widths, then you need to make certain that your delta x changes with each one of your intervals. For your next question, I want you to set aside 15 minutes once again and complete this problem in its entirety. Afterwards, check your answer. So go ahead, turn off this video, and complete this question. If you would like some more lesson practice, I'm going to suggest you look at the Barron book on page 560 to 562. The lesson follow-up is on approximation, so please get a little bit more practice and have a fabulous day.